Hello everybody, and welcome to the Poor Man's Chemist. In this video, I want to tinker around with the chemistry of the group 3 metals a little bit. The group 3 transition metals are scandium, yttrium, lutetium, and technically lawrencium, although of course that's wildly radioactive. But these metals are interesting because even though they're transition metals, most people tend to mentally group them with the lanthanides. Now, they do have a lot of similarities with the lanthanides, especially like their chemistry is dominated by the +3 oxidation state. There have other chemical characteristics in common, which I'm sure I have up on the screen there. But they are distinctly not lanthanides. They don't have any f orbital involvement in their chemistries. They fall squarely within the realm of the transition metals. Although even amongst the transition metals, they're kind of weirdos. Scandium it has a lot more in common with aluminum than the rest of them do. Lutetium and yttrium kind of like are entities unto themselves. Because of the lanthanide contraction, yttrium and lutetium atoms are about the same size and their chemistries are very similar. Now, I was going to have some lutetium until that painted dildo sold me some bullshit. And I only recently finally got enough money to where I could get some more lutetium, but it would have meant putting this experiment on the back burner, and I didn't want to do that. So I figured we would play around with these things for a little bit and just kind of show how they differ from each other and how they're different from the lanthanides and how they're, like, even if they are misfit transition metals, especially scandium, which again, likes to pretend it's like aluminum half the time. They're definitely transition metals and are grouped appropriately on the periodic table. So we have a gram of scandia here. Remember, you can always name an oxide of an element in the old-fashioned way where you drop the and add a. I guess it would be. So this is scandia. I mean, you could do it for any of them. I just like the old-fashioned names. Y'all know me. Anywho, this is a gram of that shit. And what we have here is 3 molar equivalents of KOH dissolved in water. Now, since this shit is supposed to be fairly amphoteric, we should be able to get it to dissolve in potassium hydroxide to form potassium scandate, whose formula is on the screen there. So, let's start with that. Here we go, adding it in there. I imagine that's because this shit likes to be a screaming bitch even at the best of times. Ooh, a little bit of steam. Something's happening because I haven't even had the heat on in this thing yet. Although that is the next step. I didn't think it would do much just on its own like this. Oh no, because scandium is a weirdo and has serious issues. I figure we would have to heat it up. Now, if it all goes according to what the literature says, we should predict that this stuff will dissolve in hydroxide a hell of a lot more easily than yttrium oxide will, or yttria. I have some of that here. This is not from Luciteria. This is from the same source I got this from. This is very pure yttrium oxide. And we have 3 molar equivalents of KOH here, which looks like, even though it has parafilm on it, is somehow absorbing water from the air, because of course it is. It's fine. And so we'll try both of these here. Whatever doesn't dissolve, we'll filter off, and we'll try to crystallize the product, and we'll see if we get anything. Besides, I haven't heard of anybody that's tried to make potassium scandate before, have you? That's good enough for this channel, man. Where the weirder, the better. Anyway, I'm going to let this heat up for a little bit, and then I will come back when that is done. Alright, so this stuff has cooled down now. We're going to add an excess of KOH and see what this does for us. If anything. Can we get something to happen in aqueous chemistry here. We are going to try the production of potassium scandate by combining scandium oxide, which I have recovered, dried, and repowdered here. Very nice. With potassium hydroxide in a crucible using the burner. This is kind of my last ditch attempt. I mean, we've pretty much confirmed at this point that it ain't happening by aqueous chemistry, or if it does, it's going to take so fucking long that I don't have the patience for it, and I don't think you guys do either. So if this doesn't work, man, then fuck this element, fuck this group of metals. I swear to God, it is just as obstreperous and assholistic as I remember it being in the past. Fucking swear, man. I mean, the lanthanides aren't this difficult to work with. Honestly. Fucking pissant little transition metal bitch. Anywho, sorry. Let's move on. I promise you guys, the next video is going to be better because we're going to work on recycling mercury, so... This is more one of those experimental videos where we just try shit and see what happens. And I have no idea how it's going to turn out. I have an educated guess. I read about cool shit. And sometimes it looks like it should, you know, be possible and it just isn't. It's very vexing. Alright. Get your ass in there. But if it doesn't work, at least people know what doesn't work. I am not going to measure it. We're just going to go with some. Probably more than that is going to be needed. All right. Let's go see what this gets us. I'm going to go with a low flame first because I'm not sure exactly how dry that scandium oxide is. And I don't want it to have water in it that suddenly decides to boil when it contacts molten potassium hydroxide that's, you know, 100 degrees above its boiling point. That would be bad. Probably should have waited to put the potassium hydroxide on it, but oh well. The dogs are out of the way. The only person I'm going to fuck up is myself. It's so bad. What the fuck? What is a little dark particle? Man, I swear to God, I clean that bitch. Man, is that in my KOH? Motherfucker. Yeah, burn in your hydroxide hell, whatever the fuck you were. Probably didn't even see that, which is good. All right. I should probably stir that shit, huh? Oh, well. I may not need to. It looks like it's stirring itself by convection. Oh, that's good. Hey, is there actually like some kind of shit happening here? Okay. Let's see what we got here. Good or bad? Oh, that's weird. It's a lot darker brown in real life. Look at I have no idea what that's all about. That is fucking weird. I mean, the only thing that could have been in there was scandium oxide, perhaps some residual potassium hydroxide from where I tried boiling the shit out of it in it, and I mean, maybe a little bit of residual water. But there can't have been anything else, because I didn't add anything else to it. The crucible? Nah, if it was the crucible, I think it would have done something beforehand. I don't know what to think. Well, we'll let it cool down and probably break my crucible, and then we'll play with this shit and see what the hell we can make out of it. That is odd and unexpected. Okay, people, so this is the melt, and as it's cooling, it's turning this beautiful pinkish purple color. I wish I knew what that meant. I mean, I'd like to think that it meant that it actually made something here and isn't just the molten hydroxide reacting with the crucible itself. But I don't know. I think that if it is doing that, it's probably more that blue shit up by the edge. Because that's something that I see in every one of these, and it doesn't matter what I'm working with. But, I mean, generally, more or less, that has not really interfered or caused a problem. Usually because it's just insoluble. I don't know. I don't know what to think. It's very pretty, though. Okay, bugs, if you don't stop stinging me, I swear to God, I will make clouds of poison gas to exterminate your asses from the face of the fucking earth. Very weird. Well, I'll come back when it's cooled off some more and I can add some water to it and hopefully the crucible won't break. Although it's so goddamn humid out here, I'll imagine as this thing cools down, it'll start to liquefy itself. Oh, look at the crystals in that. That's pretty. Nice, beautiful needles of something. Bugs? I swear to God. Okay, so I keep hearing the clink of probably cracking porcelain, or the melt is cracking, I'm not sure which. But we're going to add a little water to it now that it's cooled down some. I love these little squirt bottles. A subscriber sent me some of these. They're fucking awesome. Alright. Now we got a lot of white shit, which is what I expected. I expected there'd probably be unreacted stuff left over. The question is there any reacted stuff? Just more of the same. A lot more of this dark compound. And a bunch of stuff stuck to the side. It's probably not really... Oh, wow. Probably helps if it's centered. Although there's not much to see. It's just not a very colorful element, is it? But since that ain't what's happening. Alright, so here is the aqueous extract of the milk with all of the solids removed, and we are going to see if it contains dissolved scandium. Now, I am just working on the assumption that potassium scandate would be soluble to some extent. I don't know that it is for a fact, but let's see what we've got. Well, a little bit of fizzage, but this is just like the aqueous extract. Not a whole lot of anything happening here. Alright. Let's try the phosphoric acid. Oh, that's formic. Oh my god, that's not it either. Where the fuck is it? Alright, phosphoric acid. Let's try this again. Okay, once again, we don't have anything. Now that could either mean that the stuff just isn't salt. Well, wait. Oh, well. Interesting. Okay. Well, now. Ain't that something? So it did work, and we did have it. Look at that shit. All right. Well, there's scandium in there. I mean, there's nothing else that it could be that I can think of. Cha, that's... I'm pretty sure that means that it's got to be it. It depends on what the crucible is made out of. But I think that generic porcelain is just silica, which won't give us a precipitate with oxalic acid because it's not soluble. Or even if it is, sodium silicate. Would sodium silicate give us a precipitate with oxalic acid? Or potassium silicate, same difference probably. I don't know. I honestly don't know the answer to that question. Well, I will investigate that and put that up on the screen. I am a little concerned because, I mean, Scandium phosphate shouldn't really be all that soluble either.